In this video we're going to work out the line integral of this surface of this surface along this path. So the particle starts at the origin and then it moves along like this. So this is your x squared, so this is your y equals x squared, and then we're working out the area underneath this surface. So as the particle is moving along this path, you draw a straight line up to the surface, draw a straight line up to the surface, draw a straight line up to surface. So basically you're working out the area underneath the surface along this particular path. Okay, along this particular path. So let's try and work it out. So the formula we've already seen is given by this. So we've got to work out the speed. So start out by driving our particle from the origin to 1, 1. So to do that, set up your parametric equations. So x equals t, y equals t squared, and then from here obtain your position vector. So as the particle is moving like this, you always know the position vector. From the origin, the position vector is given by this. Another increment of time, so you always know the position vector from the origin. And then if you want to know your speed, you have to differentiate it. When you differentiate it, it gives you your velocity vector. So when you differentiate this, it will be 1. When you differentiate this, it will be 2t. And then this is your velocity vector, but we want speed. We want the magnitude of the velocity. So use Pythagoras, and this will be your speed. So now we can put this into here. That will then give us this. And don't forget, we're moving from 0 to 1. So t ranges from 0 to 1. T ranges from 0 to 1. From 0 to 1. And then you need to know the x location and the y location for any given time. Well, the x location is given by this. So we can put this we can put this into here. That will then give us this, and then we can put this into the y. We always know the y location, and put this into the x. So this whole thing here will then become this. So tidy this up. That will then give us well, hang on. So we are currently here at the moment. If you tidy this up, this thing here can be rewritten as this. Notice that this is exactly the same as this. So when you have something to the power of a half and then something to the power of 1, then you combine these two together to give you 3 over 2. So that will then take us to this. So now it's easy to integrate because you know that this is the derivative of this thing here. So you know you can easily integrate it. Rather than use substitution, let's try and integrate this all in one go. So you're looking for something in such a way that when you differentiate it, it gives you this. So make this to be your initial guess. 4t squared. It's going to be one notch higher. So make this to be your initial guess. When you differentiate it, it will then give you 5 over 2, the exact same bubble, and then one notch less. So that would be 3 over 2. So this matches up with this, but we don't want this thing here. So we need to go back to here, negate this thing here. So which would be 2 over 5. But don't forget, you've got to times the derivative of the bubble itself. In this case, it would be 8t times 8t. So notice that this t is right here. Well, anyway, we've done this before, so I'm expecting you to be able to do this. And also you need to negate this 8. So you need to do 1 over 8. Sorry, up here, 1 over 8. So well, anyway, this thing here is this thing here, and then tidy this up. well, this is a constant. Let's take it out here. So that will then give us this. So from here, well, anyway, do whichever way you want. We've done this in Calc 2, I think. You integrate it, it will then give you this, and then that will then take you to here, and then now it's just a matter of putting 1 into here, take away, put 0 into here. That will then give you this. So the area underneath that curve along that particular path is given by this. Okay.